Hi everyone, welcome once again to our Grade 10 Physical Sciences. Our focus today will be on atoms and compounds. Surely we had a well-deserved break. Welcome again to the second term. We shall be focusing today on the knowledge area, matter and materials, the last aspect of it, which is based on atoms and compounds, as I've indicated. Hopefully we are fresh and ready to go for the second term. Right, let's get right on to it, people. As I've said, our focus is atoms and compounds. Right. Right, as you can see from the screen, matter is the core idea, the big idea. However, we must remind ourselves that matter consists of small indivisible particles, which are the building blocks. So this is the basic unit of matter, which is the atom. Right, basic unit of matter, or the building blocks, if you may want to refer to it. So these are the building blocks of matter. These, at a microscopic level, we refer to them as atoms. Right, now these atoms, they make up what we call elements. So elements, as you would remember from the periodic table, these are individual substances that consist of atoms of the same kind. But these atoms of the same kind particularly have got the same atomic number as well as atomic mass. We're just trying to throw some bit of caution there, because remember, some atoms of the same element may differ in terms of the atomic mass. Remember the isotopes, which obviously come to mind. So elements is what you find in the periodic table, your hydrogen until calcium. You know, the first 20 elements that we have described. So these are elements, or they consist of atoms of the same kind. In other words, atoms make up elements, but these atoms must be of the same kind. Right. We also spoke about compounds in the first term. If you talk about compounds, remember compounds, they consist of atoms of different elements that consist of forces that join them together in a way that they make up substances which are a bit complex than atoms, because there is some bonding that is involved as far as compounds. So compounds are also pure substances, as you can remember. Compounds are also pure substances. Water is an example. Calcium chloride is an example. So these are pure substances. The same applies to elements. Elements are also pure substances, because we said they are not mixtures. In other words, they consist of atoms of the same kind, but these are atoms of different kinds. Different atoms that consist of forces that keep them together. So these consist of different atoms. Hence, we said atoms are building blocks of all matter. So in other words, elements are also made of atoms. Compounds are also made of atoms. Right. We also spoke about the chemical formula, which will be also our focus for today. In terms of chemical formula, remember, the names that we use to refer to specific substances are also very important, in the manner that we also go back to the periodic table and use symbols to write chemical formulae of different substances. Let's take, for example, water. We use H2O. So that's pretty much what we're talking about. Right. We're also going to talk about molecules today. Molecules are very key, because molecules can be of compounds. Molecules can be of compounds or elements. So we need also to pay careful attention to that, which will be one part of our discussion in today's session, of which, now that we spoke about compounds and molecules, elements of the same kind or atoms of the same kind can actually join together or be held together by forces, which forms giant structures. So this chemical bonding is very, very critical. And there are three types of bonding that we've spoken about. We've got covalent, right, which we shall also discuss briefly today. We also have ionic bonding. These are the different types of bonding. And also we have metallic So these are the three types of bonding that we shall discuss in detail today. Right, let's go straight to the core focus of the key concepts that will be very relevant as far as our lesson overview is concerned. Now, I want us to pay careful attention to the various aspects that I've mentioned for the purpose of today's lesson, so that at the end of the day, we achieve our set of objectives, atoms and compounds. That's the core focus of today's lesson. Right, moving on to the key concepts. Right, we shall talk about elements. Elements, we're saying these are pure substances. Right, remember, pure substances are those chemicals or substances that are not mixtures. Remember, in the first term, we spoke about heterogeneous, homogeneous mixtures. And in mixtures, there are no proportions, just maybe to bring that again so that we can draw a comparison between pure substances, mixtures. And remember, pure substances can either be elements or compounds. Elements which are made up of atoms of the same kind, as well as compounds which consist of different elements that are chemically joined together, which we spoke to bonding, which is also very important. Right. So these are pure substances. Pure substances, an element, a pure substance that can not be broken down into simpler form. Say, for example, we have calcium. Calcium consists of a specific type of atom which makes up this substance. In other words, it's not going to be scientifically or practical for us to break down calcium further without it losing its properties. We know that these atoms that make up these pure substances, which we refer to as elements, consist of these subatomic particles. But our focus is that as far as elements are concerned, they are made up of these atoms which are indivisible. If something cannot be broken down, sometimes we refer to it as indivisible. So this is another word, indivisible. This is another term for cannot be broken down, indivisible. Okay? In some sources, that's how they would refer to it into simpler form. So an example is calcium. We can take gold as an example. We can take silver. Any substance that we find in the periodic table can serve as a typical example of a pure substance, which we refer to as an element. Hence, we refer to it as the periodic table of elements. Right. Elements are made up of the same type of atom. Right. Now, the same type of atoms, let's be careful that sometimes we have atoms of the same element with different atomic mass as a result of different number of neutrons. We call these isotopes. Something just to bring to the fore so that the emphasis is that these atoms must be of the same kind, definitely not the isotopes. Right. Now, let's look at compounds. Compounds, these are groups of two or more, and they must be different, that are held together by strong forces. Now, if we talk strong forces, we also referred to the ionic bonding that you would have maybe dealt with to school as far as the first term part of matter and materials. So as far as these strong forces, we can talk about ionic bonding. Right? We can talk about ionic bonding. And remember, this one has nothing to do with metallic substances, because metallic substances, remember, they consist of atoms of the same kind. You take, for example, your transition metals. Right. Now, in this case, they are held together by strong forces or chemical bonds. These are molecules in terms of maybe covalent. We can talk covalent and ionic in this case. Right. Okay, so these atoms bond in specific ratios. Take, for example, H2O. Right. Water consists of two elements, that is hydrogen as well as oxygen. Right. Now, if you check hydrogen, in each molecule or unit of water, there are two hydrogen atoms and then one oxygen atoms. Hence, they react in the ratio 1:2. So as far as compounds are concerned, there is a fixed ratio in which these elements join together to form these pure substances. And another thing, again, that we need not forget, that compounds are also pure substances because they are not mixtures. Right. Compounds are pure substances. Very, very key for us to also include that. So having said that, I think it's very important for us to also realize the fact that what we have said as far as elements are concerned, elements, these atoms that of the same kind, rather, that make up these substances, they are indivisible. We cannot break them down into simpler form. We gave examples of calcium, hydrogen, gold, any element that you find in the periodic table is a perfect example of what an element is all about. And then as far as compounds, remember the fixed ratios in which these different atoms are combined with each other to form these pure substances. Right. Now, moving right along. Now, in terms of bonding, covalent bonds, these are formed when electrons are shared. The word core means to share, right? The word core means to share, if we can recall that. And then valent, if I can maybe make an emphasis on valent. Valent, it talks about the electrons that are found at the highest energy level, the ones that are actually involved in bonding. So these are high electrons, okay, at the highest energy level. Electrons at highest, okay, energy level, or which we refer to as the orbitals, right? So, in other words, core, it means sharing of electrons at the highest energy level. But these are particularly between atoms. It can be atoms of the same kind. So, in other words, we've got molecules, right? Molecules are formed as a result of covalent bonding. So, molecules can be molecules of elements, okay? They can be molecules of elements, okay, or molecules of what? Compounds. In other words, what we're saying is that when covalent bonding takes place, it can take place between atoms of the same kind as well as atoms of different kind. But I must also indicate that we also have atoms of elements that which exist in monoatomic form. Take, for example, the group 8, which we refer to as the halogens. Those, they don't bond due to their stability. We remember that the group 8, which we refer to as the noble gases, right? What happens is that they are the only substances that exist as atoms. So we can't talk bonding, particularly with those substances. However, if we look at elements of the same kind, we can talk about oxygen or ozone. We obviously talk about the ozone depletion every day. It's a burning issue, which is quite relevant. Now, ozone is O3. Oxygen is O2. Now, if you check, a molecule of this element consists of atoms of the same kind, which are chemically joined together. So there are these forces that keep them together, if I may put it that way. Right. It can also be molecules due to covalent bonding of different elements. We've used water as an example. We can use carbon dioxide as an example. Now, if you check, the carbon is a different element to oxygen. And also, they react in a fixed ratio of 1:2. Hence, when covalent bonding takes place, it can occur between atoms of the same kind as well as atoms of different elements. Right. Now, it also says that these form between non-metals only. Now, let's draw attention back to the periodic table, which is, I'd want to think of it as our Bible. It gives us a guide as to exactly the trends, the atomic numbers. And if we talk about classification of elements, now let's talk about the first trend. We know that the group 1 and group 2 are your metals. Then you've got the transition block, which are still metals. And then as you go further to the right of the periodic table, we've got semi-metals as well as non-metals. Now, what are we saying? We're saying that covalent bonding takes place only between atoms of non-metals. If you check, carbon and oxygen are non-metals. Hydrogen is, yes, it's in group 1, but hydrogen is an exception. It's also a non-metal as well as oxygen. So it can only take place between non-metals only. These are the typical example. We've mentioned oxygen, ozone, hydrogen, sulfur, water, petrol, which we call, it's referred to as octane, which is an organic or a hydrocarbon, which we shall discuss later in the 12th grade. Right. So covalent bonding, that's as far as it goes. Right. The most important thing now is to take home is that as far as covalent bonding, it takes place between atoms of nonmetals, and these atoms are chemically joined together. They can be of the same kind, they can be of different kind, right? And what they form what is called the molecular structure, which we shall discuss after our short break. Now, let's take a short recess now, and we shall be back after the rebound. Cheers, guys.